Let's discuss Unit 10 solutions, which is not the component of the natural language understanding process. So, what is natural language understanding? It's a branch of artificial intelligence that uses software to understand input. This input will be in the form of sentences. So, it understands input using text or speech. So, there are some phases of natural language process. So let's start with lexical analysis phase. Then it goes to syntax analysis. Then semantic analysis. These three phases will be similar to compiler phases. From there, we go to discourse integration. What is discourse integration in simple term? The meaning of a particular word or a line will be based on the previous line. Then we have pragmatic analysis. This is about interpretation. So these phases will be involved. Now they are asking which is not the component. So morphological analysis is equivalent to lexical analysis. So this phase is there. Semantic analysis is there. Pragmatic analysis is also there. Meaning analysis is not a phase in natural language understanding process. So option number 4 will be the right answer. Next question. Which is not a basic approach to the problem of conflict resolution in production system? This content is from the topic rule-based system in artificial intelligence. So under this we have something called production system. What is a production system? It is actually based on a set of rules about behavior. These rules are a basic representation that are found helpful in expert systems, automated planning, and action selection. I can give you an example. If some condition is there, then this will be the action. When a new rule is added to the database, it should ensure that it does not have any conflict with the existing rule. In case if there is a conflict, then conflict resolution strategies will be there. What it is? It is to choose which production rule to fire. Under this topic, they have given a statement like the result of the matching process is a list of rules whose antecedents have matched the current state. So, whenever it is in the current state, based on that, it will have a set of rules from which it can choose a particular action or a particular rule to fire up. So, there are three basic approaches to conflict resolution. Since there are three basic approaches and there are four options given, definitely one option will not be a basic approach. So let's see what's the first approach. Assigning a preference based on the rule that matched. So first one is there. It is the first approach. Then the second one, assigning a preference based on the object that matched. This is the second basic approach. The third approach will be assigning a preference based on the action that the matched rule would perform. So there are totally three basic approaches and all the three are listed in statement 1, statement 2 and statement 3. So option number 4 will be the right answer. This is not a basic approach to the problem of conflict resolution in a production system. So what is it? Assigning a preference based on action that the matched object should perform. No, it is the action that the matched rule should perform. That's why in the starting I told you a statement. If you want, I can just write it for your information. The result of the matching process is a list of rules whose antecedents have matched the current state. So the preference is based on the rule that is matched or it is based on the object that is matched. That is the first 2 points. Then there is another preference. It is based on the action that the rule would perform. It is not about the action of the object because that object can react to different things. But based on the matched rule, the action should be there. Next question. Which of the following is not a property of a good system for representation of knowledge in a particular domain? So there are some properties for knowledge representation. The first one is representational accuracy. This is the ability to represent all kinds of required knowledge. The second one is inferential adequacy. This is the ability to manipulate in the sense to use the representational structures to produce new knowledge corresponding to existing structure. So we infer something and then produce something new. The third one will be inferential efficiency. This is the ability to direct the inferential knowledge mechanism into the most productive directions by storing appropriate guides. When I store those guidance, I can use it whenever that particular structure or that particular data comes or that particular system comes, I can use the stored ones. So they will say, even in a game, when this move is actually saving the player, that move can be stored. So whenever such scenario arises, we can use the stored rule. So such similar scenario is this. The fourth one will be acquisitional efficiency. This is the ability to acquire new knowledge easily using automatic methods. These are the four properties for knowledge representation. We have inferential adequacy, inferential efficiency, acquisitional efficiency. Option number 1, presentation adequacy is not a property. Actually, the only property that is left out is representational accuracy. So option 1 will be the right answer. Next question. Consider universe positive integer x is equal to, and proposition is n is an even integer and q is 3 less than or equal to n less than or equal to 7 and n is not equal to 6. So let's take x first. We have 1, 2, 3, 4, 5, 6, 7, 8. What is p? P is even integer. So n is even in the sense only even numbers will be taken. And what is q? Q is actually starting from 3 and ending with 7, but it should exclude 6. 3 to 7 and not 6. I am just writing it in normal word. Okay. The truth set of P by implication Q. P by implies Q is true when both P and Q are true and both P and Q are false. Whenever P and Q are true and whenever P and Q are false, this P by implies Q is true. So we have to find true cases of P, false cases of P, and similarly true cases for Q and false cases for Q, and then find where they go true at the same time and where they go false at the same time. So this is for P and this is for Q. P is true when n is even. So I have to pick 2, 4, 6, 8 from x. P is false. N belongs to x only. So whenever n is not even, it is false. So 1, 3, 5, 7. Q is true when it is 3, 4, 5. I cannot place 6 here, though it is less than or equal to 7. It has been given that it is between 3 and 7 as well as it is not equal to 6. So I cannot include 6 here. I am just including 7 alone. It is false for the rest of the numbers when it is 1, when it is 2, when it is 6 and when it is 8. So when n is even, P I can say it is 2, 4, 6, 8. You can generally write this. And Q is 3 to 7 without 6. So 3, 4, 5, 7. This becomes the true case. Whatever number is missing inside will become the false case. This is what I have written here. P and Q when they are true. 2 is present in P but not in Q. Okay, let's leave it. 4 is present in P and 4 is present in Q. So it is true for 4 and 6 is not found here, 8 is not found in Q and 5 and 7 are not found in P. So in this case I can say P and Q are true in 4. Where are P and Q false together? One is present in false of P and one is present in false of Q. So I can include 1 here. 3 is in P but not in Q. 5 is in P but not in Q. 7 is in P but not in Q. Similarly, 2, 6, 8 are present in Q but not in P. So we'll include only 1 from this false set. P and Q are true for 4. P and Q are false for 1. Now the truth set of P by implies Q will be 1, 4. Option number 1 will be the right answer. Next question. Which of the following is not a solution representation in genetic algorithm? This solution representation will be under the topic genotype representation. There are 4 representations. The first one is binary representation. So if you take an example, everything will be in the form of binary. The next representation will be real valued representation. This will have real numbers 0.1, 0.3, 0.9, 0.6, 0.4, 0.2, 0.1, 0.3. The third representation will be integer representation. So this will be in the form of integers 2, 3, 4, 3, 4, 2, 1. Then the fourth one will be permutation representation. The solution is represented by order of elements. Say for example, let's take the traveling salesman problem. At the end, if I give you an ordering of all cities, the problem has 8 cities. Now I am giving the order of cities as the solution. 1, 5, 3, 2, 4, 6, 7, 0. If I am giving such an order, then this traveling salesman problem solution is in the form of permutation representation. The permutation of cities, or we say the ordering of cities. The numbers represent the cities. So these are the 4 representations. Let's check the options. Binary valued is there, real valued is there, permutation is also there. There is no representation called combinations representation. So option number 4 will be the right answer. Next question. Given below are 2 statements. One is labeled as assertion and the other is labeled as reason. Assertion. Dendral is an expert system. Yes, it is an expert system. In fact, the first expert system. This automated decision making process and problem solving behavior. This project consisted 2 main programs. One is called heuristic dendral and the other is metadendral. They say this heuristic dendral is called today as dendral. Assertion is true. Let's check for the reason. The rationality of an agent is not related to its reaction to the environment. Agent's action depends on various factors like the state of the environment, the time step it has reached, etc. The action is based on the preference of the agent. Whatever the agent prefers to do at that time, whether it has to react to the environment or based on the time it has reached, how the reaction can be, everything will be based on the preference of the agent. So when they say the rationality of an agent is not related to its reaction to the environment, it has to react to the environment. Agent has to respond to everything that happens in the environment. The state of the environment can alter the action of the agent. So it plays a role and it has a relation to it. In that case, we mark reason to be false. So A is true but R is false. Option number 3 will be the right answer. Since R is false, there is no question of whether it's a correct explanation or not. Next question. Given below are 2 statements. Let's take the fuzzy system components. Here we have a fuzzifier. Then here we have a defuzzifier. Here we have inference engine. Here we have the rule base or the rules. So basically there will be some crisp input. This will be sent to the fuzzifier and this fuzzifier converts the crisp input to fuzzy input and it will be sent to the inference engine. This inference engine applies rules to knowledge base to deduce new information. This is the work of inference engine. So when I say it applies rules to knowledge base, these rules will be, or the rule base will be connected here. So once it deduces information, it sends the fuzzy output to the defuzzifier. From here we get the crisp output. So the fuzzy output will be converted to the crisp output by the defuzzifier. Fuzzifier will convert crisp to fuzzy input. These are the different components. I have just given them in rectangular boxes. They are the components, but they all belong to the fuzzy system. So fuzzifier is a part of fuzzy system is true. Inference engine is a part of fuzzy system is also true. Option number 1, both statement 1 and statement 2 are correct will be the right answer. Next question, which of the following is not a mutation operator in genetic algorithm? So what is mutation operator? It is used to avoid local minimum by preventing population becoming too similar to each other, thus slowing or stopping convergence to global optimum. So there are 5 mutation operators. Let's see one by one. First one is bit flip. So I am just giving 4 values alone. What will bit flip do? If I want to flip this particular bit, then this becomes 0, 0, 1, 0. So I have flipped this bit. Only one bit will be flipped there. Then we have random resetting. So I can flip a value based on random choice. The next one will be swap. I have to swap the values based on the positions. Say for example, if I have 1, 2, 3, 4, then if I want to swap these two, then it will end up like 1, 3, 2, 4. Then we have scramble. When I have 0, 1, 2, 3, 4, 5, this will scramble certain positions. Say for example, from here till here I want to scramble it. It will become like 0 and 5 will be there. These positions will be disturbed. The arrangement will be scrambled, or the arrangement will be altered. So it can be 4, it can be 1, it can be 2, and it can be 3. Next we have inversion. This will actually inverse those selection. In scramble we selected these 4. In scramble, it has altered positions, but in inversion, what will happen is 0 and 5 will stay, and the inverse of this set will happen, like 4, 3, 2, 1. Here it is scrambled order, here it is inverted order. And swap is just altering two positions. Random resetting is just flipping any position. And bit flip is just turning any one bit to the complement, like 1 becoming 0 or 0 becoming 1. Now let's check which is not a mutation operator. Random resetting is there, scramble is there, inversion is there. Difference is not a mutation operator. When A, B and C are mutation operators, we can rule out option 1, 2 and 3. D only will be the right answer. Next question, consider the following statements. C fuzzy means clustering is a supervised method of learning. Clustering is unsupervised learning. Clustering is not a part of supervised learning. But C fuzzy is a method used in clustering. That is true, but this part is not true. So A is false. Next statement, PCA, Principal Component Analysis. PCA is used for dimension reduction. Yes, it is true. We have a topic called dimensionality reduction, and PCA will be the most commonly used method to do it. Next statement, a priori is not a supervised technique. A priori algorithm is an algorithm used in association rule mining. Association rule mining is in turn unsupervised learning. It is not a supervised technique is true. Not supervised in the sense it is unsupervised. Association rule mining is unsupervised technique, and a priori algorithm is used for association rule mining. Next statement. When a machine learning model becomes so specially tuned to its exact input data that it fails to generalize to other similar data, it is called underfitting. There are two terms called underfitting and overfitting. When the model fits the training data perfectly and when it does not do well in test data, it is called overfitting. So this is what they say. It is tuned to its exact input data, which is the training data, and it fails to generalize to other similar data as the test data. This concept is actually overfitting. So D is false. Then what is underfitting? In underfitting, model does not learn any patterns even in the training phase. So we have A and D as false. Any option that involves A and D can be ruled out. Option number 2, B and C will be the right answer. Next question, match list 1 with list 2. So let's start with fuzzy system. We have just discussed about fuzzy system. Fuzzy system will map to inference engine. B is mapping to 3. The only option that has B3 is option number 3. So option number 3 will be the right answer. Next we will see operator in genetic algorithm. Scramble. C will be mapping to 2. Next, supervised technique. In supervised technique, we have regression and classification, and under classification, we have decision trees to be one of the algorithm. So supervised technique will map to decision tree, D to 1. And obviously the expert system will be option 4, mycin. So A is mapping to 4. What is mycin? This is a computer based consultation system. From the word consultation we can understand that it belongs to medicine field. This is to assist physicians in diagnosis and therapy selection for patients with bacterial infections. So mycin is an expert system. Option 3 will be the right answer. With this we are completing unit 10 questions.